In this video, we'll cover calculations using molar mass or formula mass for molecules. So all the types of calculations that we're going to go over in this video are connected to the number of moles of a substance. Sometimes when you're trying to convert between moles and grams, what you're going to use for that conversion is molar mass, and that has units of grams per mole. And then you can also convert between moles and any of these things: atoms, ions, molecules, formula units, whatever. You can go one way or the other way back to moles. And what you use when you do this type of calculation is Avogadro's number. So we're going to cover all these types of calculations in this video. First thing to note, when you're determining molecular formulas, you may remember when you were doing this for ionic compounds, as long as you know the charge on the ion, and you can determine this in a lot of cases, at least for main group elements from the periodic table, knowing the charges helps you to determine the actual formula for the ionic compound. For covalently bonded compounds, molecular formulas cannot be determined using the periodic table. So they have to be determined a different way. And here's the general process for determining formulas for compounds. Formulas for unknown molecular compounds are determined by this process. And we'll cover the rest of these calculations in the next video for the next two sections. But what I'm doing now is showing you the basic types of calculations you need to perform the next type of calculations. So what happens is, first, the amount of each element is measured using what's called a elemental analyzer. So it looks something like this. And you put your sample in and it tells you the percent composition based on each element, like percent hydrogen, percent carbon, percent oxygen, for example. With that information, you can calculate and determine something called the empirical formula using mass percent and molar mass and some of the things I'll show you in this video. And then the next step, once you have the empirical formula, is you need to measure again a molecular weight. And molecular weight is measured using something called a mass spectrometer. So there's a lot of different types of mass spectrometers out there. This is just one of many, many examples. And once you know the molecular weight and the empirical formula, you can determine the molecular formula. So that's a long process. For ionic compounds, again, you can do those just by looking at the periodic table. Covalently bonded compounds, it's a lot more complicated process to determine the chemical formula. So building up to being able to do that, there are a couple of basic calculations you need to know how to do, and that's what we're going to cover in this video. So a couple of terminology things. So there are three names for the average mass of a molecule. There's actually four. Three of them that are listed here are all in units of AMU. So formula mass, molecular weight. All three of those things are used interchangeably and they all have units of AMU. Molar mass, same exact thing numerically. You calculate it the same way as you calculate these three. The only difference is the units are in grams per mole. So this is the one, molar mass, that we use in the calculations. So an example of determining the average mass of a molecule. So I'm going to determine this for calcium nitrate. So calcium nitrate looks like this. And this is actually an ionic compound. I said I was going to determine the mass of a molecule, but it's the same process for an ionic compound. And in fact, this is good practice dealing with ions. So just determining the molar mass of a compound in general. What you do is you find the atomic masses of all of the different atoms involved and multiply that by the number of atoms of each in the compound. So for this one, you have calcium is 40.08 plus 2 nitrogens. So the nitrate ion is in parentheses here. There are actually 2 nitrogens, so 2 times the atomic mass of a nitrogen atom, which you find from the periodic table, plus the number of oxygens. So there are 2 of these nitrate ions. In each nitrate ion you have 3 oxygens, so you have to do 3 times 2, which gives you 6 total oxygen atoms involved here. And each oxygen atom has an atomic mass of 16.00. So you do all of the math involved there, multiplying and adding, and you get 164.10 AMU for this ionic compound. And again, I chose an ionic compound here, not on purpose, but it's the same exact process for a molecular compound. For example, C6H12O6 glucose. You do the same exact process for something like that. So that is the first step, being able to determine the molar mass of a compound. The next step is using molar mass as a conversion factor. So you can go from grams to moles using molar mass as a conversion factor, or you can go from moles to grams. I'm going to go over the first type of calculation on this slide, and then I'll do an example of the other one on the next slide. So for this one, you're asked how many moles of calcium nitrate are in 20.2 grams of calcium nitrate. So in this case, you're starting with grams and you're trying to get to moles. So whenever you write out these calculations, you always just start with what you know and think about where you want to get. So I know I have 20.2 grams of calcium nitrate. And I can use my molar mass to get to moles simply by dividing by molar mass. So we determined the molar mass of this compound on the previous slide, and it's 164.10 grams of calcium nitrate per 1 mole of calcium nitrate. So grams of calcium nitrate cancel, you're left with moles of calcium nitrate, and the answer to this problem is 0.123 moles of calcium nitrate. So the next one is where you would convert moles to grams. So using that same compound, we want to know how many grams of calcium nitrate are in 1.50 moles of calcium nitrate. So always starting with what you know for these types of calculations. You know you have 1.50 moles of calcium nitrate. This time you multiply by the molar mass that you determined from the periodic table. So 164.10 grams of calcium nitrate per 1 mole of calcium nitrate. So moles of calcium nitrate cancel, and you're left with 246 grams of calcium nitrate. So there's your final answer for this one. So that's the first type. The second type takes us even a step further. So we've already looked at how you can use your molar mass to go between grams and moles. Another thing you can do is use Avogadro's number to go between moles and all of these other things. Ions, atoms, molecules, formula units. This number, this 6.022 times 10 to the 23rd, it tells you how many of any of these things are in 1 mole of those things. In this case, we're going to look at ions. So this problem says how many nitrate ions are in 20.2 grams of calcium nitrate. So what you need to do, if you're starting with grams, so you can follow this exact schematic up here, to get from grams to ions, you need to kind of go through moles. So you first have to go from grams to moles, and then you can go from moles to ions. You can't go directly from grams to ions. So the first thing you're going to want to do is convert grams to moles using that, again, molar mass that you determined. In 1 mole of calcium nitrate. And then you want to move toward ions. So you're moving away from this whole compound toward the ions, nitrate ions specifically, that are in the compound. So if you look at the chemical formula for this compound, you can use the formula for a compound. So what you can say is that for every 1 mole of calcium nitrate, you have 2. Use the 2 and you say you have 2 moles of nitrate ions. And then finally, you want to know how many nitrate ions, not the number of moles, you want to know actually how many ions. And when you want to determine that, this is where Avogadro's number comes in. So what you know is that in 1 mole of nitrate ions, you have 6.022 times 10 to the 23rd nitrate ions. So just making sure that everything cancels. Moles of nitrate cancel, moles of calcium nitrate cancel, grams of calcium nitrate cancel, and you're left with number of nitrate ions. So when you do all of the calculations involved there, you get 1.48 times 10 to the 23rd nitrate ions. And that's your answer to this problem. So those are the basics.